we're recording. So let's talk about the first bit of calculus that comes into this new chapter, transcendental functions. We're going to start off with the natural log. Now, there's a property of the natural log that is a little kind of weird, but it's absolutely true. If you were to take the integral of our reciprocal function, that's 1 over x, it's called the reciprocal function. If we took the integral from 1 to any number, that is equivalent to the natural logarithm. Now I'm going to start off by saying that for this reciprocal function, the domain of logarithm, as you just saw, is only positive numbers. So I'm just going to kind of ignore anything over there on the left. But this property states that I'll make that an x. If I integrate that reciprocal function from 1 to x, it's exactly the same as the natural log of x. In other words, wrap your head around this. The area under the curve of this reciprocal function is exactly the same as the natural logarithm. It's kind of mind-blowing. So here's where the calculus comes in. Our first rule. This chapter, chapter 5, is going to have lots of rules for derivatives and integrals. We're talking derivatives of logs and integrals of logs and exponentials and arc trig functions. And you're going to need to spend a little bit of time memorizing all the rules. But here's rule number 1 for calculus. If we want to take the derivative of this, lo and behold, we can use the second fundamental theorem of calculus. We can now tell that if we're taking the derivative of an integral from a constant up to that variable, we know that this derivative, the natural logarithm of x, is just going to be the exact same as that function with x plugged in. And that's your first rule. Don't forget that this could work with a chain rule. So, yes, if you happen to have the derivative of log of some other function u, to complete this using the chain rule, it's still going to be the exact same idea. Take the reciprocal, 1 over u, but because of the chain rule, we need to make sure we multiply by the derivative of that inside function. So we're going to multiply by the derivative of u. This is the same rule. This is straight up for just x. This is if you have some kind of composition of functions, one function inside of the other. And that's the basic rule that we're going to use there. Let's look at